Hello everyone, I am on page 19. Hoping this goes okay. You know my writing's not the best, but I'm certainly going to try. I'm going to skip the warm-up that's asking you to find the derivative and then set it equal to 0 and solve. You guys can do that and then check with the answer key. I'm going to jump in here at number 1. This should look very familiar. A container manufacturer must make a rectangular box with a volume of 8 cubic centimeters. The base of the box must be square. Let x be the length of the base of the box. We did these way earlier in the year. I believe I mentioned a few times that they would come back and we would be doing them without a calculator, which sounds crazy when we're doing them in like October, but that's what we're doing today. Express the height of the box. Okay, so I believe I have a video of me teaching this earlier in the year where I'll post it. It's not obviously going to be the derivatives one, but the beginning of the video I think will be helpful for anybody who's struggling with formulas. Like if me going through the beginning of this kind of fast is like a lot for you, then you might need to go back and redo that earlier lesson. Okay, so rectangular box. Square base. Square base is nice. We don't have to worry about like an x plus 1. Also, square base is nice because then we have, there's 6 sides total, but we only have 2 different shapes. The top and the bottom are squares, and then the other 4 sides are the same exact rectangle. If that's not a square base, then I've got 2 and 2. Okay, so keep in mind, we are always given the volume for this. The fact that it says volume and the fact that it says cubic centimeters give away that we're given the volume. So our volume formula for this is volume equals x squared h. It's x squared. You think of that as your big B, area of the base. We know that the volume has to be 8. So we always start with the information that's given, which is the volume, and then we're going to solve this for h. So I have h equals 8 over x squared. When you're asked to do one of these problems, like if this was a test or a quiz or an exam or something, you wouldn't be given part A, part B, part C, part D. It would just be one question. It's just separated out now so we can see all the different steps you have to go through. Write a function that gives the surface area. I'm going to change the size of this pen and hope that helps. S of the closed box as a function of x. Okay. Now, I'm just going up to the question and kind of scanning it with my eyes just to make sure. I know it said closed box there, but I just want to make sure I didn't contradict myself. So closed box means I do have the top and the bottom. So I've got 2 squares. They're both x squared. And as I was saying when I drew that, the other 4 sides are the same. They're all rectangles, x by h. Now, in part B, when it says write a function that gives the surface area S of the closed box as a function of x, as a function of x means x is your only variable. So right now, I have x and h. So what we're going to do is take what we did in part A and replace that h with 8 over x squared. So what happens from that first line to the second line is that this guy is just a general surface area formula. This works for any rectangular box with a square base. The second one is still a general formula, but it's more specific. Now it works for anything like this that has a volume of 8. Has to hold 8. Okay, so that would be a perfectly fine answer for part B. I'm going to simplify that. So S equals 2x squared plus 32 over x. And 9 times out of 10, it's this little algebra stuff that throws people for a loop. Like, just because this is written here should not throw you for a loop. This is like 4x over 1. So this gets multiplied to the top. That's where I'm getting the 32 from. But then I'm simplifying it. I would have an x on the top, x squared on the bottom. So that leaves me with just an x on the bottom. Okay. This is the part where we would minimize the surface area, and back in October we would go to the calculator, type it in, and find the minimum. We'd probably do a zoom 0, zoom fit, find the minimum. This time we're going to use the derivative. And the reason we can use the derivative is, first of all, we have a basic understanding of what that thing looks like. Every time we've done one of these, it's been, you know, kind of like that in the first quadrant, and this is what we're finding. Well, I'm saying we don't need to go to the calculator to find that. I'm saying we can find that algebraically, because what's special about that minimum? Well, it's going to be the only place where the slope of the tangent line is 0. Okay? And when I say the only place where the slope of the tangent line is 0, if this was class right now, I would be writing on the board, the slope of the tangent line equals 0. And then I would cross off the words, the slope of the tangent line, and I would replace it with the derivative, where the derivative is 0. So, I'm starting with what I just wrote. Yes, I'm rewriting it. And I'm rewriting it again. Label here is going to be important. Well, I guess important to me. What am I setting it up for? I'm setting it up for being able to do the power rule. So now I'm going to take a derivative, hence my s prime. Let me change colors. Should have done that first. All right, so 2 times 2 is 4x. Subtract 1 from the exponent. That just becomes an x. Minus 32, because I got that negative 1 for the exponent. X to the negative 2. What's everybody's favorite thing to do there is just get rid of the x. No, negative 1 minus 1 is negative 2. This derivative is always going to feel very similar every time we do one of these problems. Okay, so my derivative is 4x minus 32 over x squared. Great, I have a derivative. What am I going to do with it? I'm going to set it equal to 0 and solve. Because I know that if I find the value of x where that equals 0, then I've found myself the minimum. I have found that x value right there. So how am I going to solve this? I'm going to add 32 over x over to the other side. Sorry, over x squared. So I'm looking at 4x equals 32 over x squared. And then I'm going to cross multiply. I mean, there's different ways to think of this, but I'm going to put this over 1, and I'm going to go like this. 4x cubed equals 32. Do not cube root that. I mean, we're going to, but you cannot cube root it until you divide by 4. We've got to isolate that x cubed first. So 32 divided by 4 gives me 8, and I am going to take a cube root. Now, this worked out nice, you know. It's 2. If it doesn't, I would have just left it as cube root of 8. Like if 8 wasn't a perfect cube, I'd just leave it as cube root of 8. If you can simplify cube roots, you did that in Algebra 2, go ahead and do that. But if not, just, you know, if it's a random number, you know, 15, leave it as the cube root of 15, okay? This label is going to be centimeters, because if my volume was cubic centimeters, then my length for x is just going to be centimeters. And now I can find the minimum surface area. If I know what x is, I can go back and plug that x back in. Let me get my highlighter out. I can plug x in here. If they asked me to find h, I would do that. They just want me to find the surface area, so I'm going to plug x into here to get the surface area. 2 2 times 2 squared plus 32 over 2. I just took my 2 that I got and plugged it in. That's going to be 4 times 2 is 8, plus 16 is going to give me 24, and my label on the surface area is going to be centimeters squared. And that is how we do it. I don't think I need to do number 2. I think you guys can probably just try number 2. It's the exact same concept. I didn't, like I said, do A, B, C, D, but you're going to go through every single one of these pieces. And then you're going to just check with my answer key. This one says no top, so let's make note of that. So that's going to change it up a little bit when you get to your surface area. And I think you guys are going to do okay here. All right, good luck.